Okay, so today we are going to continue 7.2. Okay, so what is 7.2 talking about? It's probability of the complement of an event. Okay, the complement of an event is a sample space consisting of all the outcome of S, okay, which are not the outcomes of A. Means whatever you want, okay, the complement is the ones that are not included. Okay, the ones that are not included. Like, okay, if you talk about this, the complement of an event A, okay, is here. It's in this set. Okay, but what elements that are not included in set A are always be the one outside here. It's the complement. Okay, so let's say Q and R are two events which are defined as follows. So let's say Q is the event of choosing a vowel from the word tsunami. Tsunami, we have T, S, U, and M, I. Okay, so we need to state the complement of each of the event Q and R in the form of words and set notation. Okay, so let's see for A first. The complement of the event Q is denoted by Q prime. So in the form of words, event of choosing a consonant of the word tsunami. Okay, this is the word forms. Okay, Q prime is event of choosing a consonant. Okay, why is it consonant? Because the event Q is choosing a vowel, so Q prime should be choosing a consonant. Okay, the one that is opposite to vowel. Okay, if in the set notation our sample space is T, S, U, and M, I, so event Q is vowel, right? So we take U, A, I. So event Q prime should be TS and M. Okay, this is the way of using set notation. Okay, so how about event R? Event R is drawing a green pen from a case. Okay, the case contains black, blue, red, green. Okay, so if event R is drawing a green pen, so the complement of event R is drawing a pen which is not green. Okay, from the case, so it is black or blue or red. So in the form of notation, so our sample space is black, blue, green, red. So event R is green. So the one that is not included in green is black, blue, and red. So this is the meaning of complement. So how do we actually calculate the probability of the complement of an event? Okay, it's easy. So the probability of the A prime should be 1 minus probability of A. Okay, let's see example. Okay, so the probability that a computer network of a bank is offline on any day is 1/25. So calculate the probability that the computer network of the bank is functional on Wednesday. Okay, so our solution should be let A equal to event that the computer network of the bank is offline on Wednesday. Okay, so A prime should be event that the computer network of the bank is functional on Wednesday. So it's just directly the opposite of the probability of the computer that is offline. So probability of A prime should be 1 minus probability of A. So 1 minus 1/25. So the answer is 24/25. Okay. In a case, there are green and yellow chips. If a chip is drawn at random from the case, the probability that it is a green chip is 3/7. Okay, so there are 64 yellow chips in the case. Okay, so calculate the total number of chips in the case. So we have three things we need to let. So G is obtaining green chip, Y is obtaining yellow chip, and S is obtaining sample space. So we know that the probability of green chip is 3/7. So what is the probability of yellow chips? Okay, so probability of yellow chip is 1 minus probability of green chip. So 1 minus 3 over 7, so we get 4 over 7. So the probability of yellow chip is 4 over 7. So we do know probability of yellow chip is number of yellow over number of sample space, right? So what is the number of yellow? Number of yellow is 64. So number of yellow is substitute in 64 over number of sample space, we don't know, right? Okay, that's the one we need to find because the total number of chips is number of sample space. Okay, so 64 times 7 divided by 4, this is cross multiplying. Then you will get number of sample space is 112. So this is the total number of chips in the case. Okay, next. A box contains cubes, spheres, and hemispheres, and draws an object at random from the box. The probability of drawing a cube is 1 over 4, and the probability of drawing a sphere is 3 over 4. Okay, so we have two probability already. One is cube, one is sphere, but we don't have hemisphere, right? But the question gives us the box contains 6 hemispheres. So calculate the total number of objects in the box. So what did we do with this yellow chip and green chip? First thing we find the probability of yellow chip, right? And then we use the probability of yellow chip and the total number of yellow chips to find the total number of chips in the case. So the same thing we are going to do here. First, we are going to find the probability of the hemisphere. So the probability of hemisphere will be 1 minus 1 over 4 minus 3 over 5. Okay, and then we use 6 number of hemisphere and the probability of hemisphere to find the total number of the object in the box. So we find the probability of hemisphere first. So the probability is 3 over 20. So probability of hemisphere is 3 over 20. So it's number of hemisphere over number of sample space. So 6, you put it in. So cross multiply 6 times 20, number of sample space times 3. So 6 times 20 is 120, divided by 3 will be 40. So the total number of objects in the box is 40. Okay. This one. A number is chosen at random from a set of whole number 1 to 50. Calculate the number that chosen number is not a perfect square. So how many perfect square we have from 1 to 50? Okay, we have 7. Okay, 1, 4, 9, 16, 25, 36, and 47. So we have 7 number of perfect square from 1 to 50. So the probability of choosing a perfect square is 7 over 50. So the probability of choosing a number that is not a perfect square is 1 minus 7 over 50. So we get 43 over 50. So the answer is 8. So this will be your homework for today. Okay, it is very easy. Okay, and also this.